All right, so I'm going to review how to graph this. I went over it in class today, and the first thing that we talked about was to use a table. A table is the best method, and we found that when we plug in using a table, it really helps. The second thing I shared today in class is the vertex formula. The x part of the vertex is equal to the opposite of b over 2a. So we first have to know f of x is a fancy way of saying y, and then we have ax squared plus bx plus c, where my a is this invisible 1, my b is -6, and my c is 4. So if I'm going to plug the vertex formula in to find the x point, I would do the opposite of b over 2a. So that means that the x point is 3. So when we filled out that table, I know that the vertex is 3, and if I plug it in, 3 squared minus 6 times 3 plus 4. 9 minus 18 gives me a -9 plus 4 gives me a -5. So I know that the vertex is at 3, -5. Now, today in class we also talked about all parabolas have a pattern. So the first thing that we need to know is that a linear is just going to be a line where quadratics have this fancy U called a parabola. And I know a quadratic because it will have an x squared. So remember, it's in that formula ax squared plus bx plus c. So today I talked about this pattern. If I was to graph this, the first thing I'm going to graph is at +3, -5, I'm going to graph a point here. And all these parabolas have a pattern. The pattern is over 1, up 1, over 1, up 3, over 1, up 5, over 1, up 7, etc., etc. So notice all these ups go by odd numbers. Now some people say, well, where did you get that, Miss Maloney? Well, remember your mean math teacher made you memorize x squares. Okay, I know 1 squared is 1, 2, 3, 4, 5. And we've talked about it before, that inside of all these x squares, there is a 1, 3, 5, 7, 9. They go up by odd numbers. So I know that somewhere with x squares, y equals ax squared plus bx plus c, we're going to have this funky pattern, 1, 3, 5, 7. So what that means is since a parabola is symmetrical, from this dot, I'm going to go ahead and do a different color. From this dot, I'm going to go over 1, up 1 on both sides because it is symmetrical. And then from that dot, I'm going to go over 1 and up 3. Over 1 and up 3. From that dot. From that dot, I'm going to go over 1, up 1, 2, 3, 4, 5. Now, you probably won't do this many dots, but over 1, up 1, 2, 3, 4, 5. But this is what the parabola will look like. It always has this pattern, over 1, up 1, over 1, up 3, over 1, up 5. Now, I can check that because I can just plug in numbers. 2 squared minus 6 times 2 plus 4. Well, 4 minus 12 is -8, plus 4 is -4. And over here, if I have 4 squared minus 6 times 4 plus 4, 16 minus 24 is also -8. And notice that's where we get these points, 2, -4, and 4, -4, which were these points right here, 2, -4, and 4, -4. So obviously when I plug in my 1 squared, minus 6 times 1 plus 4. 1 minus 6 is -5. Negative 5 plus 4 is negative 1. So at 1, negative 1. And guess what? The same thing's going to happen. 5 squared is 25. Minus 6 times 5, which is negative 30. So that's going to be a negative 1 as well. So notice that this is going to look like a parabola. So there are a couple steps. The first thing I want you to know, use a table. The second thing, find the vertex using the vertex formula, the opposite of b over 2a. And the third thing, from the vertex, all parabolas have a pattern. Now these up patterns will change with other numbers. So I'm actually going to make a C video now. And I have a, B, and C video. So if you could watch all the videos, that would be great. We're going to go over one more that has a little change in that pattern.